Inserting a thin metal between the plates. So this is the effect of a metallic slab. A parallel plate capacitor has a plate separation D and a plate area A, so that's the area of these plates. An uncharged metallic slab of thickness A is inserted midway between the plates. So here is a metallic slab, thickness A, so it's put right in the middle here. So the distance between this plate and this side of the slab is D minus A parentheses over 2, and here it's D minus A parentheses over 2. So if you add these up, you will get D minus A plus A, D, the distance between the plates. Part A, find the capacitance of the device, and Part B, show that the capacitance of the original capacitor is unaffected by the insertion of the metallic slab if the slab is infinitesimally thin. That means this A is close to 0 or it's much less than D. Now you can see that when I insert this metallic slab here, because of the positive charges on this side, the mobile electrons inside the metal will flow towards the positively charged side, so there will be negative charge density developing on this side and positive charge density developing on the other side. And the surface charge density sigma here will induce a minus sigma on this side and plus sigma on this side. So basically this is equivalent to saying I have two capacitors connected in series where the distance between the plates is D minus A over 2. So this configuration, this is equivalent to the following circuit. I have a capacitor with capacitance C connected in series with another capacitor, parallel plate capacitor, with capacitance C. So there's a positive charge on this plate, negative charge on this plate, positive charge and negative charge on this plate. So you can see that these are two capacitors with plate separation D minus A over 2. So you can see that I have two capacitors in series. Therefore, the equivalent capacitance for the series connection, remember, is the product of the capacitances, C square, divided by the sum 2C. So it's going to be C over 2, where C is now epsilon 0, permittivity of free space, the capacitor plate areas A, divided by the distance between the plates D minus A over 2. So this gives me, for the equivalent capacitance of the device, the final answer, epsilon 0 A over D minus A. Now what happens if this is infinitesimally thin? So if we check the limit as A goes to 0, the capacitance, equivalent capacitance, C equivalent, will become epsilon 0 A divided by D. Or we can say that this A is much less than D, the original separation between the plates, and this is nothing but the original capacitance C0. So we obtain the original capacitance. So what do we learn? Having an infinitesimally metal inserted does not change the capacitance. Okay, so that's what we learned. Okay, so we talked about the effect of inserting a thin metal between the plates of a parallel plate capacitor, original separation D. If this slab of thickness A is put right in the middle, we can see that the mobile electrons will move in such a way that we will have a negative charge distribution close to the positively charged plate and positive charge distribution close to the negatively charged plate, and the separation between the surface charges will be d minus a over 2. This is equivalent to saying we have two new metallic plates here with minus and positive charges, and remember that this is going to be basically the equivalent effect here. So we will have two capacitors connected in series. The equivalent capacitance is product of the capacitances divided by the sum, which gives us C over 2, where C is the capacitance of one of these, which is epsilon 0 A over D minus A over 2. So this A is the capital A is the area, and lowercase a is the thickness of the metallic slab. So equivalent capacitance becomes epsilon 0 A over D minus capital A over D minus A. But when A is much less than D, it can be neglected. We recover the original capacitance. So if we have an infinitesimally thin metal inserted between the plates of a parallel plate capacitor, it does not change the capacitance.